All right, so let's talk about coordinate system number 3. Coordinate system number 3 is called the polar system. How does it work? Well, points and geometry can be specified by giving distance and angle from the last point. Now, again, I don't care what you write down. You need to be able to explain this to a 10-year-old, okay? So think about what you just saw. Think about how you would explain what polar coordinates are and what they do. For input, we're talking at distance less than angle. All right, that's our format for inputting. And then for some examples, could we say at 5, angle 45? Yes, that would be valid input, right? How about at 0.5, angle 135? Is that valid? Sure, even though there's a decimal fraction there, it's still valid. How about this one? At 4, angle negative 90. Can we use negative angles in polar? Well, you can. They would go clockwise from 0 instead of counterclockwise. So any of those would be examples of valid coordinate entry. Very good. Well, that takes care of our little cheat sheet here for coordinates. We probably have spoken, I think, about all of the points on the guided notes page here during the course of our lectures. So let's talk about the assignment. The assignment is something called BC logo, Bakersfield College logo. And what you'll be doing is you'll be creating a drawing using 3 different processes. You'll be using absolute, relative, and polar coordinates to create the drawing. So when it's all done, it will look like this. Right? We'll have BC with big block letters. We'll have a couple of flourishes and frames around them. And then down here, you're going to have your name inside the area between these 2 frames. So how are we going to get this thing done? How are we going to accomplish this? Well, please, you're not going to be using the grid and the snap mode tool, right? Because that's for babies. That's training wheels. We're learning about one of the most important elements of drawing in CAD, and that is working with coordinates. So part 1 of the drawing involves working with absolute coordinates. So start a brand new drawing from scratch like you're used to. You'll be saving it with this name, B12 2B dash your initials. And then what you're going to do is kind of like with our absolute coordinate, absolute precision assignment you did a couple of lessons ago. You're going to be plotting out the points for this figure using absolute coordinates. So on page 1018, we have the figures. Point where you're starting is down here, and we're going to proceed in a counterclockwise direction. Your job is to calculate the points for all of these corners, right? And that'll be 1 continuous series of segments to make the outline. And then the inner parts of the B are a second series of segments. And then the C is 1 shot all the way around. Right, and on page 1019, you will see that we're giving you the start point, and then you can fill in the blanks to work your way through. Okay, when we're all done, you would be able to take your written out coordinates here, and then go into AutoCAD and start plotting them. Now, a couple of things to take note of. Just like in the last assignment, not all of the corners land exactly precisely on the grid. So that means you're going to need to do a little bit of calculating, right? So the instructions tell us how large the grid is. Okay. Your job is to figure out what is half of that 1/4 inch increment, and you're going to have to either add or subtract to find the halfway point between known lines on the grid. Now, another difference from the last assignment. I tell you that this point here is 2.25x and 2.25y. But notice that there are no lines anywhere on here in the X direction or up here in the Y direction. Now, if I were you, I strongly suggest find out where the line for 2 is and mark it. And then find out where the line for 3 is in the X direction and mark it. And then find the line for 4 and mark it. Right? And do this all the way down in the X direction. Because if you don't have some points of reference, you are going to get so lost. Do the same thing going up in the Y-axis. If this is 2.25y, well, that would make this 2 in the Y-axis, right? And that would make this 3 in the Y-axis. That would make this 4 in the Y-axis. So mark them, number them, and heck, you might even want to put a little dot or a little mark to indicate where the halves are. 2.5, 3, 3.5, 4, right? Because the more information you have on the drawing to help you line yourself up will just make this so much easier to do. Okay, so take the time to set up a number line. Remember, if this is 2.25 and you have 1/4 inch squares, then you need to work backwards to find 2 and then proceed with your whole numbers in both directions. Alright, so this is part 1. And when this is all drawn, we're going to move to the part 2 of the drawing. Here's part 2. You're going to have the B and the C on your screen, and you're going to draw a frame that goes around them. So the B and the C are already there, and you're going to add a frame using relative coordinates. Now, we do tell you where to start the frame, and the inside frame is just a simple rectangle. Right, but instead of giving you a grid to work with, we tell you where to start, and we tell you how big the rectangle is. So you should be able to use relative coordinates to work your way around. And then on the outside, we got a frame that has some little flourishes on the corners. Right? Same thing. You can see how big things are, how long they are, and then proceed to use relative coordinates to make those drawing elements. Now, there's a couple of notes on this drawing I want to point out because maybe you've never seen them before. This is the note. It says this is a distance from here to here of 0.5 inches, and it's TYP. TYP means typical, means all the other ones that look just like this are the same size. So that note, typical, helps you to avoid having to put a measurement here, and then one down here, and then one down here. Same thing for the height of this. It says it's 0.25 typical. Well, it means that this one is also 0.25. And this one is 0.25. And this one is 0.25. Okay, so when you see that, it just means all the other ones are the same unless otherwise noted. Okay, so you'll have the B and the C, and then in the same drawing file, you're going to add a frame using relative coordinates. That's part 2. Here comes part 3, polar coordinates. So what you're going to do is you'll have the B and the C, and you'll have the frame around them, and you're going to add a second frame using relative coordinates. I'm sorry, using polar coordinates. Right, so on the outside here, we see distances, and we see angle. All these angles are multiples of 45 degrees. So you should be able to take the B and the C with its relative frames and then add this final element, which is a double polar frame all the way around. Okay, and then when we're done, what do we get? Well, when we're done, we get the finished drawing, which is a combination of the 3 parts and looks exactly like this. Okay, so this is what we're interested in doing. This is what we're headed toward. Let me give you a little bit more direction, and then you'll be able to start this thing and run with it.